Jeff Dyck with Solido Design. And the topic of Jeff's talk is pragmatic technical invention. We met with Jeff at Innovation Place when we were there, and then you guys are still there at the Innovation Place, right? So we've been friends for a long time. So go ahead, Jeff.
Right on. Hey, well, thanks a lot, Alan. Can you guys hear me okay?
No.
That's what I thought. There we go. That sounds, now we're live. Well, it's really good to see Jason's head on there. Jason actually taught me my first computer science class ever. And he also worked at a company called Hamilton Myriad Gate, and I went and took an internship there because I wanted to learn under him. And then he left 3 months after I joined. So it's good, really good to see Jason again, even if it's just in floating head. So that was great. Good to be back here to Vendasta too. I haven't been back for a little while, not since you got your very I guess threatening is a good word, massage chairs. If anyone hasn't tried that, I warn you in advance. The talk that I wanted to give today is on pragmatic technical invention. So I'll just give a quick intro on who I am. I work at Solido Design Automation. We're about 10 years old. We're Saskatoon based, about 40 employees, just about all technical staff. We have, I think, 2 sales guys and pretty much all technical staff there. We make one product, and it's for the semiconductor industry. It's a CAD design suite for variation-aware design in the semiconductor industry. So probably lots of customer logos that you recognize there. There's NVIDIA, if there's gamers in the house. We made your video card. Part of it, Qualcomm, if you've got a phone in your pocket, Solido technology was used to design that. And lots of great customers. The reason that they come to Solido, a little company out of Saskatoon, for technology isn't because we have a Me Too solution. It's not because we make the same thing they already have. It's because we make something that's fundamentally different. We invent things that really change the game, that improve their ability to make good chips. And that's what I wanted to talk about today is how we created this sort of invention-driven hit-making machine at Solido, and give a few tips on anyone who wants to do this. It's different inventing as a small company too. I wanted to mention that. You don't have a lot of time. You can't hide behind big money machine that's bringing cash in. You put a little bit of money into this research machine and you really need to get more out reliably. So I'll talk a little bit about how we do that. So this is our product. I'm not going to go over what everything is, but every one of these pieces here has a number of technical innovations in it. They all start with this little nucleus of invention, something that didn't exist before, that's 10 times better or 100 times better with accuracy or speed or something, coverage, something that's fundamentally different than what exists in the industry today. And then we invent that thing, and then we build a product around it and release the product, and that's our full business model. That's how we make money at Solido. So the way that we do this, what pragmatic technical invention is specifically, is we first start off by picking the right things to invent. And this is actually a controversial topic. I talk to people who do research, and they say, you don't pick your inventions, they pick you. And I don't think that's right, because imagine if you woke up one day and you've got some invention in your hand, well, you probably don't want to sell that. You probably don't want to market that and turn it into a product. It's probably the wrong thing. You probably can't afford to manufacture it or don't have the distribution channel or something. So you don't want inventions to come to you. You want to decide what you're going to invent and then go and get them. The second thing is you have to invent really quickly. You have to do things really efficiently and thoroughly such that when you say, hey, it's time to actually build this invention or the product that's going to house it, you have to make sure that it's adequately thorough such that your dev team isn't finishing the rest of the invention. So I want to talk first about inventing the right things. How do you pick the right things to invent? Simple model. It's actually based largely on product marketing. If there's product marketing people here, you're going to think about this and you're going to say, well, yeah, that's what we do when we think about, are we going to make a product in this space? We actually use it as criteria for invention. So the simple system here is we want to invent things that are valuable, buildable, productizable, saleable, and deployable. I'll talk about what all of those mean. So the first one here, valuable. The idea here is we want to focus on big problems, such that if we invent it, even partly just a partial solution, it's actually going to be worth something. So this is best done by someone with a lot of creativity, who's also a real deep expert in a specific domain. To know actually where all the bounties are, where all the expensive problems are, And to have a vision for how they could potentially be solved takes quite a bit of depth and expertise. The second thing is that we want to really order these. We want to have a list at any time of bounties. These are really just potentially solvable problems ordered by market value, so biggest problems first that are the most readily solvable. We want to have this validated by market research. We want our customers to come to us and say, yeah, if you could actually make this much better somehow, we don't know how, we don't know either, we haven't invented it yet, but if you could make this better somehow, we would pay for it. And we want these problems to be actually unsolved. So we have to keep our ears close to the ground. Usually big problems have a number of people working on them. We want to go where they ain't, because a small company, we're not going to get chosen over someone else that co-invents at the same time. And a lot of invention happens because it's timely. The right pieces are in place and things emerge at the same time. So we want to kind of go where others aren't. The second piece here, buildable. We want to ensure that we can actually make this invention. So imagine if you had the blueprints in front of you, could you actually build that? And you often can't. Sometimes things, to actually build them, there's too much funding required or talent that you might not have. There might be a whole bunch of pieces that you need to also add to the machine. That falls into the next one. Is it productizable? So an invention on its own is typically not saleable. You have to turn it into a product that is, what is this thing? You have to be able to describe the thing really clearly so that people understand it. It has to be things like safe, reliable, learnable, usable, evolvable, all these good things that products must be, a whole bunch of other things. And so we want to see that the invention makes for a good nucleus for a product. And then we also want to make sure it's saleable. If we can't actually sell this thing to the first person, second person, 10th, who are these people? Who's the 10th person? What's the demographic of the 100th person that might buy the product that contains this invention? We have to know all this stuff. What our recurring revenue model would be around the thing that houses this invention. All this stuff's really important. And the last part here is deployability. Can we actually get this out to users? Let's say people would buy it. Can we actually convert users so that it's successful, not just in the very short term with early adopters, but in the medium term and long term? So that's really the model there. It's about inventing the right things. This is extremely important. You don't just go invent stuff don't let it come to you, because that's not going to make for a good basis for a product. You're going to waste a lot of money on throwaway inventions that seem cool, but you can't actually monetize. So we want things that are valuable, buildable, productizable, saleable, deployable, and also inventable. If we pick things like time machines or dime-sized fusion reactors or something like that, well, those aren't inventable really. So you want to pick things that are actually inventable. So now that we've got a list of things that we want to invent, where if we did invent them, they'd be worth a lot, we have to invent it on the cheap. The way that we do this is we start by learning from others. This is the cheapest way to gain education about how to invent something. So study everything that's been done. What we do is two things. We get fuel to our creative fire from this. We get a bunch of ideas that maybe partly work. They fell down before the finish line, but maybe they're pointing the right direction. That's the first thing. And the second thing is we avoid failure. So learn all that you can. It's free education. Internet connection gives you most of it before you start really trying to figure out what you're going to do that's new. Then the second thing that you want to do is explore really efficiently and thoroughly the different opportunities. The way I always start this is we start with really clear criteria for success. We want to make sure that we know everything that this invention must do in order to make a good nucleus for a product. And we spend a phenomenal amount of time doing this. Because if you miss this stuff, you think you've invented something that's awesome, you take it, you build it, and you realize, it doesn't do this one thing, that it's going to fail, you got to retract it. We've done this, and it's very expensive. So really set up your criteria for success carefully. Whiteboard all this stuff up. This is where it starts. You don't start by building code at this point. You start with a conceptual model. Spend as much time on the whiteboard as you can while it's still giving you value. Make sure that it's really, whatever you invent is really, really the most elegant possible, simple possible solution. Eric was talking about simplicity in code. Simplicity in conceptual model for anything that's new is really, really important too. Complex machines are hard to build and maintain. Simple solutions are what we're targeting. So really spend a lot of time on the whiteboard, And then once you've got that, we don't want to build it yet. We're still not writing, full systems. We're just prototyping on the cheap. So model it, simulate it, something like that. Whatever is the cheapest way to discover that you can for sure meet your criteria for success. Once we've proven that we've met all those criteria, we want to ultimately de-risk this before we go to production development. So really make sure that there isn't something else that's going to cause this to fail. Because if it fails in production development, that's a way more expensive problem. So solve that all before you take this invention and try and productize it. One example, how do I do for time, Jason? Is this, oh, there's a big thing here. Awesome. I don't know what it means, though. Awesome. So one example that I wanted to give is something we invented called hierarchical Monte Carlo. We invented this in the summer of 2014, brought it to market in 2015. It was just a really successful case, and we've got a whole bunch of these big winners that we do again and again, create these nuclei that make for great products. In this particular case, we just did exactly what I talked about. We picked a really high value problem. The specific problem that we picked was that memories are over-margined. Designers, because of uncertainty and variation and no way to get rid of that uncertainty, make sure that the memory works, and they waste a lot of chip area. This is expensive, power, performance. And this is actually probably $1 billion annual problem to reduce this over-margining. So it's a valuable problem that we started with. In terms of it being buildable, productizable, deployable, saleable, it was actually perfect for us because it leaned on this environment that we already have, and it was something that we could sell to our existing customers. It really met all those criteria. So it really hit all the check marks, so we picked it. We didn't pick something harder. We picked this because we could do it. And it was going to be worth a lot when we did. Then the actual invention process for this one, we started, it was 2 guys on a whiteboard over about a 2-week period as a background task, and we worked really, really hard. We actually, we already know the area fairly well, so the expertise part was already there. We worked really, really hard coming up with different conceptual models and had 2 main breakthroughs. One is we came up with a construction of the problem such that we could actually now measure memories accurately, variation on memories more accurately than it had ever been done before, but it was going to take several lifetimes to actually run this on a 5,000 CPU cluster. So this wasn't good enough. It wasn't going to work. Then we found a way to speed it up by 1 million times. That was the second breakthrough. So I mean, this is ridiculous, right? I mean, laughing, good. One person, 1 million times speed up. We actually did that. So these 2 breakthroughs together created the real technical nucleus for this. Then we went and proved it out really cheaply. We prototyped it up, created a great benchmark suite that tested every single criteria for success that we had set out, and we proved that the thing could actually work. And then we built the thing, and we launched it, and lots of people liked it, and they bought it, and we made lots of money, and now we can invent more things. As a company that doesn't have a big fire fueling research, this is really important. They all have to be hits. They have to be designed as hits. So this is really, I think, an important process that we go through. Two main things that I can give as advice to becoming an invention-driven hit-making company. The first one is pick the right things to invent, and the second one is do them really cheaply and thoroughly. The reason I picked this is Alan said, hey, the theme of this session is the art of software development. I thought about what's actually artistic that I do at work these days. And it's not really the actual software engineering stuff. It feels more like engineering or construction for the most part. This is the part that feels artistic. This is the part where we really get our creative juices flowing, where we're trying to figure out what is the idea, what is the thing that we can invent that'll be worth something. So picking this important thing that has meaning, artists do this, they struggle with this, they think about this a lot, and so do we. We splash around a lot of ink, we go into the whiteboard, we create a lot of things, we paint over it 1 million times, iterate a lot, while we're trying to figure out, what is that right conceptual model. She's gonna blow. And then we display our art. We take this around to other technologists and we say, ta-da, here's the thing. And they look at it, and they look at it like it's something beautiful. They say, "Oh, that's really incredible." This happened to me yesterday. Actually, we were on the phone with some guys from Broadcom, showing them not this the invention I was showing here, but a different one that they really asked us for, and I showed it to them. And they were like, "Oh, that's so nice." So it felt like art, right? It felt like we had fans, we had people that actually had an experience by seeing this. And another thing that artists must do is become hit makers. They have to find formula for in a niche, and we have to do that too. So really, this process of pragmatic technical inventions, the closest thing that I do to art on a day-to-day basis. So that's why I picked it for today's talk. Anyway, thanks a lot. Any questions?
Check.
How do you weight them? Yeah, so the question, in case anyone didn't hear it, is how do you, if something scores high for some of these criteria and low on some of the others, how do you weight them? And I think really the answer is you have to have the full package. So, not everything's going to score equally for every one of the criteria. And honestly, I don't score them. I just think, does it hit all of these I think of more binary check boxes. Is it there or not? Is it worth enough to bother doing? Is it buildable enough to try to invent it? If we had the blueprints, would we try? So I consider them more as check boxes than weightings. Yeah. Yes.
You've given us a lot of frameworks and steps.
Yep.
My question is, which one do you feel on a regular basis is the hardest one, and how do you overcome that?
Yeah. So the question is, what is the hardest piece of this framework, and how do you overcome it? I think the hardest thing is picking the right thing, and lots of people have said this. It's more important to do the right thing than to do the thing right. It's or something like that. I probably misquoted it, but I think that the key thing is picking the right thing, because if you pick the right thing and you fail to invent it, well, okay, try the next right thing. But if you pick the wrong thing and you successfully invent it, well, it's not going to make for a great product down the road. So even if you're able to invent something, if it's not really the right thing, it's not going to turn out very well. In terms of which of the criteria are the most important, I think it might, part of your question is that too. Valuations is usually fairly easy once you think of the thing. It's really the creative process of looking for that thing that's worth a lot. So you're out there, you're meeting with your customers, and you're looking, well, why did they do that way? That seems really inefficient. Can I do better? Can I do 10 times better? Can I do 100 times better? Yeah, I think I actually could. Finding those opportunities, kind of seeing them, the ones that are actually attainable potentially, that's probably the hardest part is observing the opportunities, in your domain. Takes a lot of expertise, I think, to do that. Yeah. Yeah. Yeah, think of it as musicians making an album. You're trying to make hits, but you're going to have some B-sides for sure. So not everything is the big thing that's going to sell the most. You've got some big hits. The ones that are misses should still be profitable if you're actually going to take them to product. So that's what we really look for. To answer the second part of your question, is things that are definitely going to be worth. If I can invent this and bring it to production, I'm definitely going to make money. So everything makes money, but some things have higher margins than others. So you got your big hits and your B-sides. The second question is, do you ever miss? Well, the big misses, I think, are, here's the thing, we haven't missed in a while, but we used to miss a lot. So we learned this through iteration, failure. Wisdom is a product of failure a lot of the time, as long as you're able to study it, learn from it, avoid it in the future. And we really studied our failures, and we found out why were these investment dollars that we spent on invention not fruitful. Sometimes we'd succeed on everything we tried to do, but it made for a terrible product. Or sometimes we'd succeed on everything that we tried to do, but we couldn't actually build it later. So these are actually all reflections of hard lessons. So I wouldn't say that we started with this framework and we're always successful. This is really, we become hit makers because of failing a lot and understanding why we failed. Yeah.
Any other questions? I'm going to throw it too hard.
Alan the Punisher.
Sure thing. So with respect to having a product that's saleable, making something that's so niche, it seems like it might be difficult to pitch it on people. How do you find the right people within that company that can appreciate your pitch?
Yeah, that's actually a really, really good question about the semiconductor. Being in Saskatoon and selling to guys that are clearly not here, we don't have a semiconductor industry here. There's no one that I went to school with I can go and ask who's an old buddy. The way that we earned this is our co-founders, one's here tonight, Amit, they actually started a previous company in this space, so they had some connections when they first started. And then having some friends that are on the ground, friendly customers is really important. Then as we, worked away at this, the first couple were really hard. We didn't have good intel. We didn't know if it was saleable, and because we didn't have good people to ask or not enough. But over time, once we started building up a customer base, I've got 100 people I can phone up right now and just say, hey, do you think this is a good idea? And they're all, principal designers at Broadcom and Qualcomm and ARM and stuff like that. So, people that really know the answer. We know all the purchasing guys. They're already our customers. So we can ask the technologists, is this worth something to you? We can ask the purchasing guys, will you pay? So we've positioned ourselves to be able to verify salability. Yeah. But it's a really hard market to crack. Yeah.
Okay, one more question? No? All right.
All right, thanks.
Okay.
Thanks, Alan.
Thank you very much, Jeff.